graphical problems are very common in maths, but in particular also appear a lot in the sciences. A graph is just a good way of representing two different pieces of information against one another, and the skills that you learn here are ones that you might take all the way to university if you pursue something like a scientific career. In general, graphical problems I've split into these different sort of topics, but they're all strongly related to one another. This first one here is graph equations, okay? Because we can always have a graph which is just two pieces of information here, expressed usually by what we call the y-axis and the x-axis. And in both of these cases, we can have some kind of way of relating these two bits of data. Now, the x could be anything we want to really. In maths, we just keep it as x. But in, say, for example, physics, it could be something like, say, distance. And then if we had this y one here, we could call that maybe, say, velocity and get a slightly weird looking time graph. And we're always going to have some kind of relationship between y and x. And the most common graph equation is that y is going to be equal to x, which is then multiplied by some value, which we call the gradient. This is represented with the letter m, okay? And then that'll give you an idea of how much y increases compared to x. But of course, this means if we substitute in x equals 0, y should then also equal 0. It's clearly not true in this graph because when x is equal to 0, which corresponds to here, y is equal to some non-zero value. We call this value c, which is the y-intercept, okay? So the full equation here is y equals mx plus c, okay? So the way you figure out c is you figure out what is x when it is 0, and the gradient you have to calculate as, well, if we actually look at this equation here, in a weird way, we could think about dividing by x, okay? We could say that y divided by x is going to equal, well, it's going to equal m plus, and then we get the c over x. We're not too worried about that because the c is just a constant that gets encoded in there, so not to worry about it. So the way we calculate the gradient is a change in y over a change in x, because that change is what gets rid of that c term. And the way you do that is literally measure off the graph. You figure out what is the y value here. We'll call that, say, y2. What is the y value here? We'll call it y1. And then similarly, when you've got these two different values here, we've got a corresponding x value and y values. This would be x1 and x2. Okay. Divide one by the other, and we'll get the graph. So we'll do that with some actual practice in a minute for finding the tangent. Very, very, very common skill. Next one we're interested in is tangent, a word I just mentioned. So tangent just means a straight line coming off of something. And when you have a graph that is not necessarily a straight line, so we're just going to go for a graph here where we've instead got this sort of nice looking curve. It's not immediately obvious how you'd figure out what the gradient is, because with the gradient I just said change in y over change in x. However, it's curving during that section, so it's not like we can put one point to another easily. So instead, a tangent is where you draw a straight line coming off of this particular shape here. And that straight line should match up, if I move this in here, with one of the points on the graph. And that straight line comes off of that graph itself. So it's at this point here. And then it comes off of that graph and they form a 90-degree angle. This is one of those things that you get very good at with practice, but generally you take the ruler and just draw a straight line, so if you zoomed in really hard, it was just going to touch that point. A tangent should also generally not touch the rest of the graph if you've got something like a square graph, but it inevitably will if you've got a more complicated graph. Again, something we'll get with some more proper practice when we do the exam question. The last one here we have is rates of proportion, which is a way of, rather than using graphs, but instead we're going to be talking directly about the equations that link two pieces of data. For example, in that last one, that was a square graph, so we might say y equals x squared, and we might then consider what this graph looks like in comparison to, say, the opposite, y equals the square root of x, because different systems in the world have different rates of proportion, and we need to know how to represent all of them. So we're just going to move straight on to exam questions here, because the exam questions are pretty much the basis of all these examples anyway. So this is not an exact exam question. This is one that I pulled off of BBC Bitesize, but it's a very close approximation for the kind of questions that you'll get for straight line graphs. You might be asked, what is the equation in this graph? Just a reminder, the thing that we're heading towards is y equals mx plus c. C is the y-intercept, and m is the gradient. M is how much is y changing when we change x, okay? Now, uniquely, this graph is actually going down as x increases. As x increases this way, y is going down. So we know this is going to be what we call a negative gradient. Basically, it's one that says if we increase x, y has to go down, So m must be a negative number. We'll find that in a minute. So to find c, we have to figure out what is y when x equals 0. So if we go to x equals 0 here, we can see that y is equal to 2. Okay, so when x equals 0, y equals 2, so c is equal to 2. Okay, now to find the gradient, that m, we have to do the change in y divided by the change in x. Now, in the case of a straight line like this in maths, which has been made on some graph paper, we can afford to be a little bit less precise. However, the reason that you do this in a scientific scenario is you'd want to pick a very wide range in data. This minimizes the kind of errors you're going to make, and it's something that we should do here just as good practice. So I'm going to draw this triangle here that clearly links up the entire graph. So we're going to do the change in y. Okay, so y over here is plus 5. So y2 up here is equal to plus 5. Okay, y1 down here is equal to minus 4. The change in y is going to be how much there is a difference between the two of these values, which is going to be 9. If you wanted to show that using an equation, you do 5 minus 4, because the difference is the two of them subtracted, but this minus 4 here contributes a minus sign. So change in y is equal to 9. We then do the similar process for the change in x. At this point, I'd recommend maybe pausing the video and seeing if you can do this bit yourself if you're unsure. But change in x is going to be equal to, so we've got x1 over here, and then we've got x2 over here. I've labeled this the wrong way around to what you might see in a textbook, but it doesn't matter as long as you're consistent, it doesn't matter. So in this case, we have 4, and in this case over here, we have minus 2. So the change in x is going to be, well, we know there's 6 squares between them, so it's going to be 6. But again, if you wanted to represent that, you do 4 minus 2. Okay, so the change in y over the change in x is then going to be 6. Okay, so the change in x is 6 and the change in y is 9. But I've not been fully correct here, because I mentioned before that m has to be a negative number in this case. And this is a fairly classic trap to fall into when you're doing things like this in maths. So instead what we have to do is make sure that either m is a negative number and recognize this shape. If you think about it with shapes, that might be the better way. Alternatively, if we're really being consistent about it, what we should have done is if we're doing 4 minus 2, we should have done minus 4 minus 5 for delta y. So change in y is actually negative 9, because as x has increased by 6, y has decreased by 9. Okay, so our full equation is y is going to be equal to, and then we get minus 9 divided by 6 x plus c. It's common practice to simplify our equation, so we get y is equal to minus 3 over 2x plus c. And that's the equation of this graph here. That's how you determine it. That was very long-winded. I wanted to make sure you had every single step. I will say that as you get more practice with this in biology, chemistry, physics, and maths, you'll get very quick at doing these graphs, and you'll decide on your own personal method and ways that you would write down these different variables. But you will get very good at these. So, tangents. A container is filled with water in 5 seconds. The graph shows a depth of water d centimeters at time t seconds. Okay. The water flows into the container at a constant rate. Which diagram represents the container? So in this one, we have to do a bit of visual imagery, which is very common in graphs because it also relates quite closely to shapes. So as we can see, we have a graph that initially is going at a constant rate, and then it slows down. The way I like to think of this is that between 3 and 5 seconds, we only really change the depth by 5 centimeters, which is terrible. It's not really much in comparison to earlier, where between 0 and 2, we changed it by 15. So we want a shape where we get an initially large amount of water, then it slows down. So A would be constant, that'd be a straight line. D would have a weird wiggly shape. B would end up increasing as time goes on because the depth is easier to fill. So it's actually C in this case, where you have to have more and more water to increase the depth. So the answer for that is C. And use the graph to estimate the rate at which the depth of water is increasing at 3 seconds. And the way that we do that is at 3 seconds, that corresponds to this point here. And we'd have to draw a tangent. I'm going to make this into a nice red color so it's clearly visible. We draw a tangent for 3 seconds. That point there. Okay? And that tangent is going to be parallel to the surface at that point, but otherwise makes a 90 degrees to it. And then it makes 90 degrees to the rest of the curve, I should say. So then how we figure out the rate of change of something is the gradient. So at that point, we just take a gradient again. So we go from this point down to this point, And then if I pick another color here, these 2 points here, okay? So change in y is going to be equal to, let's take a look, but 25 minus 15, so that's equal to 10, and change in x, which is equal to 4 minus 1, which equals 3. So we can estimate that the rate of change, in this case, is going to be equal to 10 over 3, which is about equal to 3.3. And that means that the water is increasing by 3.3 centimeters every second at this point. The last one is rates of proportion, which is one interesting one, which is which graph represents the information where we have y being directly proportional to the square root of the distance x. So y is proportional to the square root of x. That's another way of saying it's equal to, but multiplied by another number. But when we put it into a graph, it just gives a shape. This is a useful trick you guys might not know. For the square root of x, what we can do is draw on what y equals x squared would look like, which will be something like this, okay? And then to take the inverse of a graph, so the opposite operation, which in this case would be y equals the square root of x, we'd actually draw a straight line from the origin, and then we'd see the reflection. Now, I've already drawn this on C, because as you can see, these two are a reflection of one another. As we end up seeing y equals x squared increase, this graph here will decrease at the same rate. And so the answer in this case is C. And that's how you determine the proportionality of these. I want to leave this last one as a bit of a challenge for you guys. A 100-mile journey costs £36. What's the cost of a 250-mile journey? So we got to think is that in this case, y, 100 miles, is equal to the square root of 36 times by some number, we'll call it, say, a. And then what you got to figure out is, what's it going to be for 250 miles, given it's going to be the same a, square root of some answer. Anyway, guys, I encourage you to give your answers at the bottom. If you've got any questions, please feel free to also put them down there and I'll answer them. And hopefully this has helped you with answering some graph questions in maths and in subjects beyond.